Hi there. Thank you for clicking on this practice set for domain and range. Now, this domain and range assignment is going to focus on quadratics as a family of functions. And as you work through the problems, remember what domain and range are. Always keep your eye on the definitions and what we're trying to find, not so much the patterns that you might see come up in quadratics, because we want this study of domain and range to carry over into other function families. Please like and subscribe if this video is helpful. Ask me a question or give feedback below, and check out the other videos that we have on the channel. Now, as always, pause the video to work these problems on your own, and then come back to check your work. State the domain and range of the quadratic functions below. Okay, now for these first ones, these ones I'm showing the graph for them, but you can actually sketch these fairly quickly on your own without using a graphing utility. And that goes back to transformations on functions. So you might want to go and get a refresher on transformations. I'll put a link up there. That's a lengthy lesson, but one that transfers over into lots of families of functions. So if you learn it well, it saves you a lot of time later. Okay. And where you can go with that is if you remember that this +3 is going to send you left 3, and that +1 is going to send you up 1. From the parent function, there's your left 3, there's your up 1, and you actually don't need to graph it to be able to find the location of the vertex. So that can save you a lot of time. Now, for all quadratics, all of them forever, okay, the domain is all real numbers, and you can express that using either the funny looking R or using what's called interval notation. Hey, everything from -infinity to +infinity. If you don't know what those mean, please go and look at the lesson for this problem set. Now, range can be a little bit trickier, and we want to, again, focus on what the definition of range is, not the particular specific patterns that come with quadratics. And the range is all of our y values, get that right. They are all of our y values. So if you were to look at that point right there, the y value for that point would be 4. There'd be another point over here that also had a y value of 4. So you know 4 is in the range because it is one of the possible y values. And because this is a continuous function, like 3.99, okay, would also be in the range, 3.99, because there is some number there. The smallest y value, though, is this 1. Okay, once you go below the 1, there's no more parabola down there. So whatever you plug in for x, there is no way you are going to get a 0 out for it. And you can even reason that out. If you take a number and you square it, okay, you take a number and you square that number, the smallest that could be is 0. If you have a positive number and you square it, you're going to get a positive. And a positive +1 is even more positive. If you have a negative number and you square it, you will get a positive. And a positive +1 is still positive. Now, if you have a 0 here, which you could have a 0 there, that is weird. Do I want to save? I need to pause this recording. Okay. All right, I think we're done. That was very, very weird. And I'm so sorry that happened. And now I don't remember what I was saying. But the like now I don't know what I was doing. That was a weird pop-up. Okay, but anyway, the smallest this can be is a 1, and it goes upward from there. And so we would express the range as y is greater than or equal to 1. And I think I was going through like the smallest this could ever be is 0. If you plug in a -3, -3 + 3 is 0, 0 squared is 0, and then you add 1. And so, and there you can see the vertex there, you can kind of reason that out. But if you're taking something and it's positive or like and then you add 1 to it, you can, the smallest it could ever be is 1, and then it could be bigger from there. So again, remember the definition of range. What can we get out? But there's no way you're getting a 0 out of that, because you can't take something and add 1 to it and have a 0, unless this could be -1, which it can't be. All right, similar thing here with the transformations. We know that a negative out in front will flip. We know that the +4 will send this left 4, and that the +5 will send it up 5. And lo and behold, oh, look, guys, it goes left 4 and then up 5. And then you can see that it is flipped over. So you don't really need a graphing utility to do this. You could probably do it just as fast. The domain for every quadratic is all real numbers. Please use the notation or verbiage that your teacher would want you to use for that. And then in this case, the range, okay, again, looking at all of those y values for all of those points, there is a maximum y value when you get up here to y is equal to 5. You're able to get a value of 5, but nothing above a 5, okay? Nothing greater than a 5. There's no point on that parabola that has an input-output that's going to land you at greater than 5. Therefore, it's 5 and anything less than 5. And the way we would write that is y is less than or equal to 5. Now, for the next two, these ones are in standard form. So these ones, it's probably easier for you to graph them on a graphing utility and just find the vertex. But you can find the vertex by using the formula for it. So just as a quick little review here or refresher, my A value is my A value is 1 and my B value is -8. And so the formula for finding the vertex is the opposite of B over 2A. The opposite of -8 is +8. And then we have 2 times 1 is 2. And that gives you the x coordinate of the vertex. Now look down here. Oh, look at what the x coordinate of the vertex is. It's a 4. And then to find the y coordinate, you plug in the x coordinate and just evaluate it. And you might be able to use a calculator for that. 4 squared is 16. This will be -32 plus 13. 16 minus 32 is -16, and -16 plus 13 is -3. Oh, look. All right, so if you don't have access to a graphing calculator, you can't just dump it into Desmos, you can do that. And it's not a huge amount of work. Just be careful about order of operations and dealing with positives and negatives, like that kind of thing can be a bit of an issue. All right, so we have the domain. Don't overthink it. It is all real numbers. Okay, and then my range in this case, it's bottoming out at that -3. Okay, that's the smallest y value, and then it's upwards from there, so greater than the -3. And so we would say y is greater than or equal to the -3. How do I know it can be equal to -3? Well, like right here, when I plug in 4 as that input, I get -3 as the output. If you go back to the domain and range mapping, it means that if you have a 4 in the domain, it maps to a -3 in the range. Okay, so that's like what it means in terms of that mapping. So -3 is part of the range. And last one, we have this one here. And again, I'll just kind of work through this for those of you that maybe don't have access to a graphing calculator. The opposite of 6 is -6. My A value here is -1. So I have -6 over -2, which is +3. Oh, look, wow, it's +3 is my x coordinate. And then we're going to plug in that 3. And so this will be -3 squared, which is, this one is -9, not +9. So it's a little bit different than if you were squaring a negative because we're not there. -9 plus 18 is +9, and 9 minus 10 is -1. Oh, wow, look, -1. So you do have that vertex of 3, -1, and you know that this is flipped over because that leading coefficient is negative, so it would flip it over. So if you needed to do a quick sketch of this on your own, hopefully you can do it. Domain, please do not overthink this. It's all real numbers, or everything from -infinity to +infinity. And my range this time is maxing out at that -1. That is the highest it can be. And then it goes downward from there. So downward would be less than the -1, but it could also be equal to the -1, because when 3 is in that input position, -1 is in the output position. So there we go. So that is 4 domain and range problems. Hopefully you came close. If you didn't get them exactly right, that you made some corrections. You can go back and redo them again, take a day off, come back, like, I'm going to rework those again, see if I can get them right the second time. All of that is valuable. Okay, don't forget to like and subscribe for more math content. Drop a comment or question below, and check out the other videos and playlists on the channel to help support you in whatever you are working on in your math class. I hope to see you in a future video.